Hi Graham, here's question 19, and I wanted to do this one in a separate video because it's longer, because you actually have to do integration by parts twice on this one. So I've got the first one set up for you over here, and if we put that into the u v minus the integral of v du formula, then this is what you end up with for the first round of integration by parts. This is a times here. Just stick an x in there for times. Minus the integral from 1 to 2 of v du, which is going to be 1/2 e to the 2x. Now I could write that 1/2 in front of the integral sign, but I'm not going to do that because du, when I multiply v du, I've got a -2 there, and the -2 and the 1/2 can cross out that way, so I get rid of it permanently, which is nicer. And so now I'm just going to leave this part alone here. And for the integral, if I clean that up a little bit, this is what I get. Okay, so the negative here times the negative here is going to enable me to change that to a positive. But I'm still left with the integral of x e to the 2x dx, okay? And so when you look at that, it's actually going to be an integration by parts. Again, so round 2. And this time, we're going to make u equal to x. That makes du equal to 1 dx, or just dx, okay, because the derivative of x is equal to 1. I'm going to make dv equal to e to the 2x. And so again, v is going to be 1/2 e to the 2x, okay? So what I'm going to do with that now is this big long thing, I'll write in blue to show that this is the second part, because we're doing the second integration by parts now. So that's from left over from the first one. Now what I have to do is plus uv again, because when I integrate this one by parts, it's like doing a separate question. So doing this one again is going to be the uv minus the integral of v du. So u is just x, and v is 1/2 e to the 2x, minus the integral from 1 to 2. I haven't been writing that in every step, sorry. Integral from 1 to 2 of v du, and that's where the simplification of the du comes out for us, because it's just dx. So now I just have one function that needs to be integrated, and so when I integrate that, I'm going to get the integral of the integral of e to the 2x is 1/4 e to the 2x, okay? And since this is a definite integral, in other words, they gave us the interval that they wanted to evaluate from 1 to 2, now we're going to go and we're going to substitute 2 in for x in each of these terms, and then we're going to subtract 1 in for x for each of these terms, and we're going to take those two answers and we're going to subtract them. So I won't go through all of that work because it's just really plugging numbers into the equation. I will tell you, though, that there is a really neat antiderivative calculator. I'm just going to go over a page here. If you're having trouble with these, and you go to symbolab.com, and solver antiderivative go down to the next line. There's a dash calculator. That is a really neat free software program on the computer that will not only give you your antiderivatives so that you can check to make sure they're right, but it will also show you your steps, and that will be really helpful. The trick with integration by parts is always choosing the correct u and v so that the function will simplify each time rather than getting more and more complicated. And that's a little bit tricky, especially when you're first learning derivatives. So it's always nice to have something like that to sort of build your confidence and let you know that you're doing it correct, or to show you the right way to choose them if you're having trouble and you're stuck on that part. So I hope that helps. And please email me again. My eyes are getting better now, and I'll be able to get on the computer more regularly. And then maybe we'll see you on Thursday. Okay, thanks.